Hello and welcome to our next Tech Tip series on Superheat Part 2. In this video we're going to talk more about superheat and we're going to keep it short and sweet. Superheat is the suction low pressure vapor line temperature minus the boiling point low pressure saturation temperature. We had talked about this in the last video that we would prefer to utilize the temperature that a refrigerant is boiling and or condensing at versus looking at the pressure. So superheat is the suction line temperature as measured with a thermal clamp on the suction pipe minus the boiling point or low pressure saturation temperature, which is the temperature the refrigerant's boiling at in the evaporator, which will be indicated on your low pressure gauge. Regarding superheat, we would prefer to utilize the manufacturer guideline for the superheat range for that system. However, that is not always available on older systems and may not be applicable if it is a mismatched system or there are some issues in regards to the installation of the system. Perhaps the ductwork is not the proper size, or there may be some issues relating to when the system was installed that the customer really does not want to address. So the service technician's job is to attempt to maximize the performance of the system in the way that it was installed. So the alternate range that I have found to be is the superheat should be greater than 5 degrees and less than 25 degrees in fixed meter and device systems. Now, a fixed meter and device system is a system that uses a piston actuator, a capillary tube, or uses the restrictor in the distributor. This type of meter and device does not regulate. It merely allows a fixed flow based on the pressure differential, the difference between the high side and the low side. The size of that orifice or meter and device is determined by the manufacturer based on the evaporator coil and the condenser coil. On split systems, there may be a change required in that metering device or that fixed orifice relating to the specific type of condenser or evaporator that's installed. The superheat usually is going to be greater than 8 degrees and less than 15 degrees with a TXV, which is a thermostatic expansion valve metering device. Now, this type of metering device regulates based on superheat. So if it is set for a 12 degree superheat, then its purpose is to regulate the refrigerant flow through the evaporator to maintain that 12 degree superheat. So the superheat setting of that expansion valve will be between 8 and 15 degrees. Electronic expansion valves refer to manufacturer's service manual or superheat range. To know what that is, you really will need to refer to the manufacturer's service tips or service tech information. The temperature reading that you're going to take, preferably you want to get as close to the evaporator as you can. However, that's not always convenient. You can't necessarily get to that and check your suction pressure as well to get your boiling point. So you will more than likely be checking it on split systems at the outdoor unit. And factor in or consider how long that line set is and is it well insulated. Now, I want to get into the different conditions that we look at in regards to superheat, and those conditions are starved and flooded. Starved condition is a higher than normal superheat. Superheat range we had just talked about, that temperature is higher than that range, and we consider that to be starved. Flooded is the opposite. It is a superheat that is lower than the normal superheat. Starved indicates high heat load in the evaporator coil versus refrigerant flow. Flooded indicates low heat load in the evaporator coil versus refrigerant flow. And you're checking the boiling point versus the suction line temperature to get superheat. You don't know at that point whether you have a low load condition, a high load condition on the evaporator coil. You also don't know whether you have an overcharge, low on freon, or restriction issue. So what you're doing by checking superheat is verifying if you have a flooded condition or a starved condition. If my superheat's high, I'm starved. Superheat's low, flooded. This then leads you in a direction to take to determine why that condition exists and what best means are to remedy that problem. So, starved condition is a high superheat. Now, this can be a low refrigerant charge. Low on refrigerant, so we have less refrigerant going through our evaporator coil. This will cause a higher superheat. Could be a restriction, which is creating a reduction in refrigerant flow. This would be a restricted metering device or a restricted dryer. Generally, with a restricted dryer, you're going to notice a temperature drop over the dryer when the system is running. When the system is on and it's been running for a few minutes, you want to check that temperature from one side of the dryer to the other. If you notice a temperature drop, then that generally will mean that there is a restriction in that dryer. If you look at the metering device, and if you notice that the metering device is frosted on one side of the metering device, and this is regarding air conditioning, not refrigeration, then that means that on the one side of the metering device, boiling point is higher than 32 degrees on the inlet, and on the outlet going to the coil, it's lower than 32 degrees. Now this would indicate that the metering device is restricting. Now that's a normal operation for that metering device. But if your dryer is not indicating a temperature drop, my primary pressure drop is happening at the metering device. We're going to discuss this in more detail in later videos, but at this point, and just want to clarify that a restriction will usually be in the dryer or in the metering device. So too much heat load on the evaporator coil. Now this can be caused by a broken return duct that is in the attic drawing in hot attic air. Typically what we find when we have a high load condition that causes a starved condition on the air conditioning system. The flooded condition, which is a low superheat, can be an overcharge of refrigerant, can be low heat load on the evaporator coil, and this is very common where we may have a blocked air filter where the size of the filter really does not sufficiently allow airflow with a pleated type filter. So maybe they need to go to a fiberglass filter. It's typical throwaway furnace filter that will allow more airflow. Or a clogged coil. Could be that the unit was ran without the filter for a while and the coil got clogged. Could be a crushed duct. That could be a crushed supply or return duct. Or in a light commercial application, it could be a loose belt. And that's very common to see loose belts on the blower, and that will cause a flooded condition. Now going back to the overcharge, believe it or not, it is pretty common to find systems that have been overcharged. And that's typically because the technician who overcharged it was not following the starved and flooded condition guidelines regarding superheat. They were merely adding Freon based on the boiling point of the evaporator. And usually when they do that, they're not even checking superheat. They're just adding refrigerant to get that saturation temperature or boiling point above 32 or 35 degrees. And that will lead to an overcharge condition. So that's it for this video. Our goal is to keep them short and sweet. And please stay tuned for the next video where we will continue this discussion on superheat and troubleshooting.